Okay, students, let's do one more related rates problem. And to remind you, there's some strategies that you can use when doing these problems. The first, of course, is to read the problem carefully, and you may need to do it more than once. That's okay. There's no shame in having to read the problem again. Draw a diagram if at all possible. We've done that before. Remember, we did that with the police cruiser problem. We also did that with the tank problem, and we're going to do that with the problem here in a few minutes. Introduce notation. That means variables. You got to introduce variables. And again, that's something that you would do in a word problem anyway, so that's really not new. So you want to write an equation that expresses everything, and then you're going to use the chain rule to differentiate. And then within the problem, see, the given information is going to be usually your variables and also some of their derivatives. So you have to pay attention to the words in the problem. They may not tell you the derivative directly, but you have to pay attention to the language. It's going to be there. You'll see. Use the chain rule to differentiate both sides, and then finally at the end, notice that it's the last step that they tell you to substitute. So a common mistake is to substitute too early. Okay, so don't do that. That's what I call a rookie mistake. Okay, so the problem that I want to do, it involves two ships. Okay, at noon, ship A is 100 kilometers west of ship B. Ship A is sailing south at 35 kilometers per hour, and ship B is sailing north at 25 kilometers per hour. How fast is the distance between the ships changing at 4 p.m.? So look what's being asked for is how fast the distance between the ships is changing at 4 p.m. So we're going to have to draw a diagram. So this is the initial situation. Ship A is 100 kilometers west of ship A. Ship A is sailing south. Ship B is sailing north. So what I'm doing right now is I'm introducing variables, right? What is x? X is the distance ship A sails south. What is y? Y is the distance ship B sails north. And at any given instant, we could find the distance between them, can't we? D, of course, is the distance between ship A and ship B. So notice what I'm doing. I draw the diagram, I introduce the variables, okay? Now from our diagram, let's see here. maybe you can be convinced that we have a right triangle. See, I can slide this x here to the right, so I have an equivalent situation here. The hypotenuse is going to be d, so I have d squared is equal to the horizontal piece is 100, so we have 100 squared, plus the vertical piece is going to be x plus y. So right here is the expression relating everything. Now, back to our problem. See, what we're asked for is what? The rate at which the distance between the ships is changing at 4 p.m. Well, 4 p.m. just means what? They've been sailing for 4 hours because it starts out at noon, right? So what is x dot? In other words, what is dx dt? Well, we were given that ship A is sailing south at 35 kilometers per hour, and ship B, right? So remember, y is the distance that ship B goes north, is sailing north at 25 kilometers per hour. So at 4 p.m., let's see, 4 p.m., that's 4 hours past noon, right? Ship A is sailing south at 35 kilometers per hour, so what we need is 35 times 4. So x is 140, right? And then y is going north at 25 kilometers per hour. Multiply that by 4 because it's 4 hours later. Y is 100. So x plus y is 240. See, I'm going to need d in this situation. So d squared is 100 squared plus, see, x plus y is 240. So d squared ends up being 67600. In other words, it's 67,600. So d at this instant is 260. So at that instant, at 4 p.m., the ships are 260 kilometers apart. All right. So again, d squared is equal to 100 squared plus x plus y squared. Now what we're going to do is we're going to differentiate. What we haven't plugged in yet is the derivative. So if I differentiate both sides, what do I have? I have 2d times d dot equals. Now the derivative of 100 squared, that's 0. That's a constant. So this is equal to 2 times x plus y times the derivative of the inside here is going to be x dot plus y dot. Now I can divide both sides by 2, right? And I get d dot equals x plus y times x dot plus y dot. D we just said is 260. So 260 times d dot equals x plus y. Well, x plus y is 240. And then what is x dot plus y dot? 35 plus 25. So solve this equation for d dot. And that will be our result. So we have $60 times 240. Divide that answer by 260. And we got d dot is about 55.4, and this would have to be in kilometers per hour. So what we're asked for is how fast the distance between the ships is changing. Well, the distance is increasing at a rate of 55.4 kilometers per hour.